AI does not imagine scenes the way human beings do. When you type a prompt, the system isn't picturing a living world in its mind. It is calculating visual patterns based entirely on the specific words you feed it. If you type a vague command, like create a city, you force the network to guess. Without explicit parameters, the model defaults to the most generic, muddy average of its training data. To eliminate that guesswork, you need to structure your input. Every prompt should explicitly answer 4 variables. What is the subject? Where is the environment? How is it captured? And what is the style? Stop treating the generator like a chat window. By shifting to a rigid framework, you stop hoping for a good result and start directing the system to execute your exact vision. Professional prompt engineering breaks that framework down into a strict 7-part formula: subject, action, environment, lighting, camera, style, and quality. You build out this formula layer by layer. Start by defining the subject and action. For example, a red sports car drifting. Next, inject the environment to give that action context. We add the instruction, rainy paved street. Finally, apply the stylistic constraints. Add neon reflections for lighting, a low angle for the camera, and cinematic for the style. Constructing your prompt sequentially allows you to isolate individual variables. You can adjust the camera angle or tweak the time of day without scrambling the rest of the underlying image. Using subjective adjectives like beautiful or awesome gives the AI no mathematical data to work with. You must replace them with precise technical vocabulary. Image models are trained on professional photography, which means they prioritize industry-standard commands. Using terms like golden hour, softbox, or high contrast gives the model exact lighting values to compute. This image shows an extreme high contrast, low-key lighting setup. Notice how the lighting command dictates the sharp drop-off into shadows and the distinct catch light in the subject's eye. The technical term creates the exact mood. You also need to explicitly state what the AI should ignore. Negative prompts act as a filter. By placing high negative weight on terms like blur, distortion, and bad anatomy, you strip away artifacts before the image renders. By explicitly commanding the model to exclude specific patterns, you mathematically eliminate anatomical errors, fixing things like 6-fingered hands before they even render. Producing studio-quality imagery is entirely about applying a strict sequential data structure to constrain the prediction engine until it has no choice but to render exactly what you want. That formula gives you a perfect still image. But the moment you apply that same static description to a video model, the entire prompt collapses. Motion introduces time, and time breaks static physics. The process requires you to stop thinking like a passive viewer and start thinking like a cinematographer. You are translating emotional intent into hard optical data. To control video, we inject 2 new mandatory variables into our equation: action and camera movement. The AI needs explicit instructions on subject behavior and virtual lens movement. Instead of interesting angles, use precise cinematography vocabulary. Terms like Dutch angle or slow dolly forward act as mathematical vectors, giving the AI a strict path. The syntax you use for these variables changes completely depending on whether you are generating video from scratch or animating an existing image. For text-to-video, you are building a scene out of nothing. You must start your prompt by defining the camera movement and the setting first. You establish the environment, then describe the subject inside. Image-to-video requires the exact opposite structure. Because the scene already exists, your prompt begins with the subject, followed by camera movement in relation to that subject. You pair these rules with the right model for the job. Based on the 2026 benchmarks, if you need aggressive, cinematic camera motion from a text prompt, you format for Kling 2.0. If your priority is absolute physics consistency across an image-to-video sequence, you structure your prompt for WAN 2.1. Mapping the correct syntax structure to the specific architecture of the model strips away the ambiguity that causes objects to melt into the background.
Even with perfect syntax, current AI video models share a hard limitation. They cannot maintain physical and temporal coherence over long, continuous clips. The longer a single shot runs, the higher the probability that the physics will break down. Bypass duration limits with multi-shot sequences. Generating short, discrete clips constructs a complete scene. Splitting actions, like knitting to organizing clothes, resets physics calculations, extending runtimes without hallucinations. Image to video maintains identity consistency, seamlessly transitioning a character from playing guitar to recording a song on his laptop. The entire system relies on stacking these methods. You build your base assets using the progressive detail approach, you animate them using the struct text-to-video or image-to-video syntax, and you stitch them together using a multi-shot sequence. Here is a professional prompt. Futuristic motorcycle drifting through a neon-lit urban canyon. Low-angle tracking shot pacing alongside the bike. Harsh volumetric lighting, hyper-realistic style. Every word has a specific job. Effective prompts rely on clear structure. Check. Subject, action, environment, camera, lighting, style. True cinematic AI is never achieved by searching for one magic sentence. It is built by architecting a calculated series of highly constrained data points.